Hello everyone, and we are back with lesson 4, that is rectangles. From the module 2, we are dealing with quadrilaterals. We dealt with parallelograms and now we are going to study about rectangles. Let's go look into the learning objectives. They are to recognize and apply the properties of rectangles and to determine whether parallelograms are rectangles. The keyword is rectangle only. Now, before we go into this, I hope you remember the last two lessons about parallelograms. Rectangle is also a parallelogram. It is just that there is one important property: all the sides are 90 degrees. It is a proper parallelogram. Only thing is, parallelogram generally can have any angle, right? It's not restrained to having 90 degree, but rectangle is a parallelogram with 90 degrees with all the four sides, and all the four angles are equal. That's the only difference. Now here there are few properties. You might relate few of them with parallelograms. All four angles are right angle. This is the extra one, new one. It's not something parallelogram has. But this opposite sides are parallel and congruent. Yes, even parallelograms, opposite sides were parallel and congruent. Opposite angles are congruent. Yes, absolutely yes. Same with parallelogram. Consecutive angles are supplementary. Yes, even with parallelogram. And diagonals bisect each other. Yes. Other than all four right angles, we have remaining same to parallelogram. Now, here there is one extra thing, that diagonals of a rectangle are congruent. Now, if this is the diagonal, now imagine we have 5 here and 10 here, and then over here it's 5 again and 10. Now, DB is a diagonal and AC is a diagonal. Now, how do you find any diagonal? Let's go with AC first. You can use Pythagoras theorem. Pythagoras theorem, square root of the sum of the other two squares. That's 5 squared plus 10 squared, right? Now, let's find the diagonal B and D. What is, for B and D you can use any. It would be again square root of 5 square and 10 square. So isn't it same? So this is the thing. Diagonals of rectangle are congruent. They are same, equal, because the opposite sides are equal. It's not only that, it's 90 degree. Whereas in parallelogram, though they were equal, it's not 90 degree. You can't use Pythagoras theorem. You can use using trigonometry, but it may not be the same. So that is the extra thing. Okay. So in rectangles, we can always find that the diagonals will be congruent to each other, this and this. Okay, it should come over here and over here. Okay, so that is the thing. Now we will move on to problems, and one more thing is, if parallelogram is a rectangle, then the diagonals are congruent. That's it. Now here we have to use properties of rectangles. The coach is making the basketball team run a new drill along the diagonal of the court as shown. Now here you can see these are the diagonals, right? The coach is making the students run along the diagonals like this, to run like this, diagonals. Now they have shown if BC is 94 feet, if the B and C, see this one, is 94 feet. FC is given to be 106.5. This one, F and C, is 106.5. Find D and G. They want us to find, I'll draw it in blue, this D and G. Now, this is not at all required. This is just to mislead you. Now, here you can see G and D is required, or DG, whereas you know FC. Here, what you can do, this is a first of all, here they have told to use the properties of rectangle. So this is a rectangle here. You can see it's 90 degree. So now you must know when in a rectangle the diagonals are equal. So this is the first thing. The diagonals are congruent to each other. So if this is 106, then this entire B to D would be also 106.5. So this is it. Then what next? You don't want the entire thing. See, diagonals bisect in a parallelogram. Rectangle is also a parallelogram. Here the diagonals do bisect. So what happens is, if this is x, this is also x. Now we know the total distance. So all you need to find is this half, right? So you can just do 106.5 divided by 2. That would be answer. It'd be 53.25. That is the answer. So here you know FC, these two diagonals are equal, so BD would be 106.5, and because the diagonals bisect each other, we can tell this plus this equals total and just divide it by 2. So divide 106.5 by 2, you will get 53.25 feet. That is your answer. You can this is in detail, but you can use just a couple of steps and find the answer. Now here, this is a very interesting problem. Please do pause the video and try how much you can solve. Now here this is a rectangle. Now J is forming a barn door with X brace as shown. See, this is the braces. That's like a support, you know, for the door. It's like gives you more strength. Now if RT, can you see this R and T, is given as 3, 9 by 16, and QR, can you see where is QR? This is QR, the straight one. So let me just change the color over here, and this is QR, that is 7 feet. Measure of RTS, let me change it again, RTS, that's RT and S, this angle over here is 65 degrees, okay, 65 degrees, and we need to find each of these measures. So they are given as a diagonal length, a side length, and angle. Let's first find PS. What is PS? We know QR is 7, PS is the opposite side, it must be congruent and it must be 7. That is very straightforward. What is SQ? Now here we know this distance, right? TR. We know the diagonals will be equal. So what is PR? It is this multiplied by 2. And whatever is the answer will be SQ. Why? Because SQ is basically this diagonal. So SQ and PR is same, or you know TR is over here. So multiply this by 2, that would be the diagonal length. Any one diagonal you find, it's the same thing. Now how would you solve it? 3, 9 by 12. How would you solve this improper fractions? See here, whatever is in the denominator is multiplied with the whole number and added to this. It's this multiplied this plus this, in the sense 12 multiplied by 3 plus 9 divided by 12. The answer would be 12 times 3 is 36 plus 9 divided by 12, and 36 plus 9 equals 45 by 12. Don't go to solve this, you can divide 3, yeah, we can simplify it. 3, this is equal to 3 4 times, and 3 10 15 times. So 15 by 4 would be the answer. And now multiplied by 2, the answer would be 30 by 4. This is the final answer over here, 30 by 4, or it is 4 7s are 28. 28, yeah, it's this. Let me just double check it, so we can use the calculator over here. 30 divided by 4. So I did a mistake over here, but anyways, so 30 plus 9. So what I would suggest is use your calculator. I can't wrap around where I went wrong. Oh yes, I know where I went wrong. I have taken the question altogether wrongly. It's 16 here, and that was my mistake. It should be 16 everywhere, and then you'll find it. But anyways, I will show you how to do it in calculator. So you should just multiply 2 here, multiply this by 2. No, this entire thing is wrong, you know, this is 16. Anyways, sorry for that, but I will solve it anyways now. 3 9 by 16. So again, important thing, I'm not gonna edit that because it's important to do mistakes, but it's important to learn from the mistakes. So when you copy from the question. If you have done a simple error, then the entire answer is wrong, just like what I did just now. I will attach a video on how to solve these problems without calculator. It's always the denominator multiply this number 16 times 3 plus 9, then divided by the denominator. So the answer would be 16 times 3, 16, 32, 48. 48 plus 9 divided by 16. Anyways, this is simple. Now I'll show you how to directly do in calculator. Can you see the symbol over here above this fraction? Don't use fractions. Now if you're thinking, okay, what I'm going to do, I'm going to use the fraction 9 by 16 and then I'll put 3 over here. This is wrong. This is wrong. It'll multiply itself. If we are to solve, you should add them. Add with this. But how do you understand? It's easy. You need to press shift and this. Now just type it as it is, 3 9 by 16. This is equal to 57 by 16. See over here, 48 plus 9 will be 57 by 16. This is the answer for T and R only, because RT is given. Now this is the answer. Okay, now if you're not using the shift and this symbol, you need to plus 3 plus 9 16. Okay, always remember it's like that. Or if it's given like this in the question, you shift and this symbol, please remember. Now you need to multiply this by 2. The answer is 57 by 8, that is 7.125, which is the length of Q and S, or SQ, because it's the length of PR, and PR and QS are equal. Now we will go to the angle QTR. Now RTS is 65, QTR is how much? Now always remember, this would be supplementary in the sense Q and S is a straight line, isn't it? A straight line will have an angle of 180 degree. So 180 degree is the total angle if you add 65 and this QTR is unknown X. So it will be 180 minus 65, that is equal to 115. So that would be the answer over here, 115 degrees. And lastly, we have to find TQR, this angle. Now this angle is required. Now over here, TQR is unknown. We know this angle, right? QTR is 115. What else do we know? Now one important thing here, this and this angles are same, 115. Okay, these both are same. These are vertically opposite. That's not required much. But now if you look carefully, this and this is equal, this and this is equal, right? These diagonals all are equal. Now if you look carefully, this diagonal and this diagonal is equal, these both are basically an isosceles triangle. Look over here, this side and this side equals to each other. That means the bases must be equal to each other. This base and this base must be equal. Why? That is the property of isosceles triangle. We have studied that previously in the previous grade, 9th grade. So isosceles, yes, isosceles triangle property is the base angles are equal. So now if I take this as X, this is X. And what about this angle? This is 180 degrees. Sorry, it's not 180 degree. It is 115. Now if you add them all, 115 plus X equals 180 degrees. And now here it will be 2x, that is equal to 180 minus 115, 115. This will be 65. Now you must divide this by 2 because it's 2x. So x would be 32.5 degrees. That would be the final answer. I hope this is clear. See, each of this is an isosceles triangle. So you can see these sides are equal. So the base angles will be equal. The legs are equal. Base angles are also equal. And then you can equate these two both as equal. But you just need what? TQR1 of x. So solve it and you will get the answer. I hope this is clear. If not, you can just go back and check through this again. Now then, we will go to the second type of problem where we have been told this is a rectangle and we have been given some measurements and we have to find the value of x. How do we do this? Let's first see what is given. BAC is given, this one, this angle, that is 3x plus 3. Now another one is ACB is given, this one, that is 5x minus 1. What is unknown? X value. Now you can do one thing. I remember, because now these problems, then coming problems as well, can be solved in different methods. I have already done this lesson in class. When I was doing in class, my students were doing differently, especially Umran Khalfan, because I was really impressed, because he had used different unique methods and he was solving all different problems. So I remember that. So I'm just telling you, you can use your own methods and you can solve it. It may not be the method I'm solving, but that is correct. Okay, I mentioned the student's name because I remember he did different methods and he got and he was solving it by himself. You will get the same answer. As long as you get the same answer and using the correct method, that's fine. Now I will use one of the basic method. This is 90 degree, which is given. Here you have one angle mentioned, one angle. Now what is known? This triangle is known. Sorry, that's not a straight line. Okay, can you see that? So that triangle is known. So we know the interior angle, the total angle of a triangle is always 180 degrees. That is equal to what? 3x plus 3 plus 5x minus 1 plus 90. And now solve it. You can just use the calculator directly, or let's do it. Over here, 2x plus 5x is 8x and 3 minus 1 is 2. 2 plus 9 is 92. 180 over here. Take 92 to the other side, it will be 90 minus 2, that will be 88, and a is equal to 8x. Divide both the sides by 8, you will get 11 equals x. This is the correct answer, 11x. So you can see the answer would be x equals 11. Sorry, not 11x, x equals 11. 11 equals x. So this is the correct answer. Now here they have just asked you to find x. That's it. Stop it. It's over. Now you can also understand these are alternate angles, and then this can be equated to 90. So what I mean is, this angle and this angle are alternate angles, right? You can equate this to 90 degree and solve it. But anyhow, whichever is easy. What I did is I just wrote what is given to us, and which is easy, plug in the values, anything. And other than that, there are other methods as well. So what else? Here, quadrilateral JKLM is a rectangle. They have mentioned this is a rectangle, but they have not asked us to prove rectangle. They have asked us to solve for M and K, this length, the diagonal. But they have told MN, this is 3x plus 1. Okay. And JL, can you see this entire thing? JL is 2x plus 9. Now here it is interesting. Why? Because they have told MN is given. MN is given. And JL is given. JL is given. How are they related to each other? MN is half of JL, because JL is the entire diagonal. This is half, right? You can write it like this. MN is equal to half of JL. Or you can take 2 to the other side. It will be 2 times MN equals JL. Why? Because JL is the entire diagonal, whereas MN is just half of it. Now we can substitute the values and solve it, isn't it? 2 multiplied by what? MN is 3x plus 1 equals JL is 2x plus 9. Why we remove this half to the other side is it's not complicated. It's a bit harder to divide rather than multiplying. You know, it's comparatively division will cause a bit of problem, whereas multiplying is easy. So we multiply here. 2 times 3 is 6x plus 2 times 1 is 2 equals 2x plus 9. And we take 2 to the other side, it will be 6x minus 2x, and 2 over here, 2x other side, number 2 to the other side as well. 9 minus 2. What are you going to get is basically 4 equals 7. 4x equals 7. X equals 7 by 4. 7 by 4, that is 1.75. 1.75. That is the answer of X. Now, very important thing. We have found X value. I'll write it over here. You can pause the video and check this steps. Now, X value we found out by equating 2 times Mn equals JL as 1.75. But this is not what we want. We want MK. MK is equal to JL. So I will take JL value, that is 2x plus 9. But instead of x, I will substitute 1.75 plus 9. Okay. And just use a calculator directly over here and solve. It will be 2 times 1.75 plus 9. The answer is 12.5. So MK is 12.5. So this is how we solve MK, the diagonal. Now in the second part, they have used angles. We need to solve for angles. How do we do that? J and K is given, this angle is given to be 5x plus 2, and J and M is 3x minus 6. Now you need to find the measure of each of it. So first you need to find the x value. Now you can see this is a straight line, MK, diagonal, right? The angle is 180 degree, linear line, 180 degree. So this plus this is equal to 180. 3x minus 6 plus 5x plus 2 equals 180 degrees. And now you can just put in the calculator directly to solve, or we'll do it manually. 5 plus 3 is 8x. Take this everything to the other side, will be 180 plus 6 minus 2. This becomes plus, this becomes minus. It'll become 184 8x. So 184 by 8 would be the answer. 184 divided by 8, 23. So x value is 23 here for the angles. But that is not the answer. You need to substitute J and K, right? J and K. Substitute 5 into 23 plus 2. And then same thing over here. 3 into 23 minus 6. These would be answers. Okay. So 23, 230 half is 115 plus 2 is 117 is J and K. Here 69 minus 6, 63 is the answer. So this is how we solve 117 and 63 degrees. That's how we can solve these problems. First solve for x and then substitute back in the required value and then solve it. Now we will be proving parallelograms are rectangles here. Now the thing is, you need to just remember a few things. One of the theorem that the diagonals of rectangles. See, diagonals, if the diagonals of a parallelogram are congruent, then the parallelogram is rectangle. Now this is one important thing. Diagonals, if it's a parallelogram, now imagine diagonals are only congruent for rectangle. It's not other way around. So if at all we find this diagonal and this diagonal equal, over, it is a rectangle. That's it. That is what we need to do. Now here let's see, they have given us AB value to be 50 and BC over here, BC is again 20, AD is 20, CD is 50, AC is 54, BD is 54. Okay. Now looking at this, you need to know it is rectangle, but we need to prove it. So let's see. Here you can see this AB and CD. See, there are other ways to prove as well, but now I'll just go through this, what they are saying. AB and DC, CD are congruent. And you can see, sorry, BC and AD are also congruent. Okay, and also the diagonals are congruent. Now here, sorry, one here all you just need to do is see, prove, reason. Now here, since the opposite sides are congruent, see, both the opposite sides are congruent, it's a parallelogram. You just tell that, see, all these opposite sides are congruent, it's a parallelogram. Step one done, parallelogram done. Now next step, all you need to tell is the diagonals are congruent, because it's given over here already. If the diagonals are congruent, it is a rectangle. So parallelogram and then rectangle, that's it. It's just an understanding problem. And remember, the beginning of the problem I had done by using 5 and 10, that is kind of a proof. You can use this only for diagonals, only for rectangles. You can see the diagonals will be equal. So now we will see another problem. Here they have given you all this, you need to fill in the spaces. So this my if you remember in one of your exam last time, the writing part, similar problem had come where there was empty spaces and you have to write this. So now let's see this. They have given you that PQRS is a rectangle. They have already told, and also they have mentioned PT and ST are congruent, this and this. Okay, we need to find QT and RT. Now first one is given, that is whatever given, you just write it out. That is PQRS is a rectangle and PT is congruent to ST, that's given. Now PQRS, if it's a rectangle, then it's obviously a parallelogram. That is the definition of rectangle. All rectangles are parallelograms, but not all parallelograms are not all parallelograms are rectangles. Okay, but all rectangles are parallelograms. Now here, third one, if you're thinking why all rectangles are parallelogram, because if you're rectangle, you will obey the laws of parallelogram. But not all parallelograms are rectangle, because you can be a parallelogram but you don't need to be 90 degrees. So not all of them are rectangle. Okay, now here, third one, unknown value, unknown statement, but they have told opposite sides of a parallelogram are congruent. Now opposite sides, now since we are dealing with this and we will use this and this side rather than this and this. We will use these two sides because they are adjoining, opposite. So we can say RS and QP are congruent, they are the opposite sides. Now what is definition of rectangle? Over here you can say that these two, these congruent sides are equal, angles, sorry, S and P. Can you see this S and P? Right angles. Why? Because if it's a rectangle, that is that the ends must and should be 90 degrees. Now what about S and P? S and P, can you see this S and P? Here they are all right angles, right? Now we will just see what is known. This is right angle, same angles, this is same sides, and we just told that these both are same. Side angle side, SAS postulate, which we had studied last term. So side angle and side proved. See, now we know triangle RST and triangle QPT, they are congruent from SAS postulate. Now in this SAS postulate, if we find any side, then angle and side congruent, then those triangles are entirely congruent. Now from congruent parts of congruent triangle are congruent. That means if these two triangles are congruent, then each part, corresponding parts are congruent. So now we can say this is equal to this, this is equal to this, this is equal to this, and QT will be equal to RT. That's how we prove it. This is the proof. This is how we solve it basically. And now we are going to the last parts of the problems. We have to identify rectangles and coordinate planes. Now here There are different ways to solve it. First thing, I will tell you about the distance formula since they have told distance formula. You can use the distance formula at GH, HJ, JK and KJ. Apply all the four sides. GH and KJ must be equal and this must be equal. Then yes, it's a rectangle. I mean, it's a parallelogram. But if you have to do it has a rectangle, then you must know whether this is 90 degree. So one thing is that the best and the easy way would be the diagonals. If the diagonals are equal, over, that's it, they are equal. Now here you can see the the slope as well. If since a coordinate plane is given, you can use Pythagoras theorem. This will be 90 degree. Then you can find this side and compare this side, then this would be 90 degree and you can find the angles are equal. I mean, there are various methods, okay, whichever is easy, you follow it. So there are plenty of ways you can figure out over here. Over here, what they have used is, since they have told distance formula, they are doing a long method, but honestly they are required because you know why? Because you're proving it's a rectangle, it's not a square. So diagonals can be equal even for a square, right? So we must make sure this opposite sides are equal, these opposite sides are equal, and the diagonals are equal. So first of all, how do you do this distance formula? I'll write the distance formula here. It's x2 minus x1 the whole square plus y2 minus y1 the whole square. All you're doing is see this point. What is g? G is given already, but you can count minus 1, 2, 3, minus 3, comma 0. And h is 1, 2, 3, and 1, 2, 3, comma 2. So g and h, it will be x1, y1, x2, y2. Substitute. x2 is 3 minus of minus 3. The whole square plus y2 is 2 minus 0 the whole square, and take the square root of all. 3 minus of minus will be plus, so 3 plus 3 the whole square plus 2 minus 0 is 2 square, square root. Over here we will get 9 square plus 4. 9 square is 81 plus 4, and it is sorry, one second, what did I miss? It should be 40. It is 85 here. Let me just quickly see what is the mistake. Okay, it is 3 plus 3. I made it 9. I multiplied it. My bad. It's just that I'm tired, I guess, and you know, my mind is not as fresh, so I'm making clumsy mistakes. Sorry for that. Here it's not 81, it is 36. 6 squared is 36 plus 4. The answer is 40, square root 40. Same way you need to do it to all the lines. You can see here for all the others, and then you can see they are opposite sides. So yes, it is a quadrilateral, and wait once again over here. Let's just see this. The same method is applied everywhere. And one more thing, okay, this is a good thing to do. Since I have used x1 and x2 differently, I got root 40. But even if I take this as x2 y2 and this as x1 y1, you're going to get the same answer. Look at this textbook method. Here they have taken the other way around, x1 y1, x2 y2. Answer will be the same, doesn't matter which method you do, okay, as long as it's correct method. Now we found this is a parallelogram. Now what you do is determine the diagonals. So this is the diagonal GJ, G and J. Solve it. Same thing with KH. Solve it. This and this, okay? Sorry. Now the lengths are over. These are the diagonals. And now all you need to do is find them. You get the same answer, root 50, root 50. Yes, this is a rectangle. It's a lengthy method, but this is how you prove this is a rectangle. Is that okay? So don't just jump looking at the the figure, because it may not be exactly to scale. Sometimes they might mention it, the figure is not to scale. So just make sure you do at least few of the curve quickly. You can try to do the solving and then check the answer. Now here we have a MCQ problem. A quadrilateral has vertices A, B, C, and which of the following ABCD is a rectangle? So now what I did in class was I was just plotting it out. 1 2 1 2 3 4 5 and 6. You can use all of them and do the distance, but it's going to be crazy and it's going to be forever. Now let me just 1 2 3 4 5 6. So what you can do over here is let's plot these points. 1 2, this is 2, and 1 2 3 4 5 6. Okay, that is not that great spacing. Let me make this as a 1 and this will be 7. Okay, so I can adjust that over here. This is 7. 1 2 3 4 5 6 7. Now you can see 2 and this is 6, and we need 3 and 4. So these are few of the main points highlighted over here. So let me do first. A value is 2 and 6. 2 and 6 somewhere over here. A. What about B value? B value is 3 and 7. 3 and 7 somewhere over here. Now what about C? It is 6. Okay, 4 5 6, and this would be 7. Okay, just in case. 6 and it would be 4. That's over here. 6 and 4 somewhere over here. Now if you see properly, how would you draw a rectangle? It would be either like this, somewhere over here. This would come down, or it could have been like this, isn't it? There are only two ways. So what you can understand from here is, so this is having a difference over here of 1, this is having a difference of 1. So this next point can be either right side or left side. It can be either 5 or 7, and here also it can be either 3 or 5. Okay, it's either 7 comma 5 or 5 comma 3. Only these are the possible answers. Why? It should either shift down and move left, or it should go up and move right. This is the only possibilities to make this a rectangle. So now easily you see over here whether there is any 7. 7 is not there at all, so that's not possible. It can be only this. So this is wrong. 5, we needed 5 and 3, so A is correct. This is the answer. So you can go a little innovative in this, and you can easily find the answer without any calculation and anything, just by graphing and understanding this. Okay, so this is how we can solve this problem, and that is the end of this lesson. I really hope you have found it helpful. There were some mistakes which I did, and then I realized that were mistakes. I've not removed anything. It's important to do mistakes to learn, so that you won't do the same mistakes in the final exam. So please learn from others' mistakes as well, and so you don't repeat them. Make sure when you're taking values, take the correct values, and while calculating, if you're getting confused, just use calculator. Don't take the risk, and use the proper values. And you can solve these problems in various methods. All methods would lead to the correct answer itself, provided you use the correct do the method correctly. So that's it. That's it for today. If you have not subscribed to my channel, guys, please do subscribe to it. It would mean a lot to me. I would really appreciate it, and I thank all the subscribers. Thank you so much. And if you have any doubts, any questions in this chapter, please drop them in the comments. I'll try to get back to you as soon as possible. And have a great day. Take care. Bye-bye.